So one of the banes of the renal fellow's existence is a CRRT machine clotting off. In fact, fellows get a lot of phone calls about CRRT machines not functioning correctly, and usually those phone calls happen in the middle of the night. So let's try to figure out a mathematical equation, and there is such one actually, called the filtration fraction, which ought to give you an understanding of how likely the filter is to clot off, and it'll also give you some important insights in what you can do to prevent it from clotting a second or third or fourth time around. So we're just going to draw a simple CRRT machine here. And this is the blood flow coming in and the blood flow going out. And we're going to, make this the effluent. Yes, there we go. Here's your effluent flow. And so the filtration fraction is really a very simple mathematical equation, but it's going to be helpful for you because it'll hopefully keep you asleep at night. The filtration fraction is really what comes out, what comes out divided by what you put into the filter. This is the general equation for filtration fraction. Now let's expand on these terms a little bit more so you have a better understanding of them. The effluent, we know, is what you get out. So in the case of CVVH, you have a replacement fluid that's coming in here, right? Or in the case of CVVHD, you have a dialysate fluid that's coming in here and then coming out. So the effluent is going to be the flow of either your replacement fluid or your dialysate fluid. Either one of these, the green number, plus whatever you take out from the patient, which is going to be the ultrafiltration rate. Alright, so this is your effluent that's coming out. It's a combination of what you take out from the patient, which is purple, and what you take out from your replacement fluid or your dialysate fluid, which is green. Now let's talk about your blood flow. It's actually not your blood flow that's being looked at in the denominator. What you really need to know is what's something called renal plasma flow. And renal plasma flow is really your blood flow multiplied by 1 minus your hematocrit. Your hematocrit is a percent, and it indicates how much of the blood is red blood cells. 1 minus that percent is everything else that's in the blood, that's plasma. So if you really wanted to be technical, your filtration fraction in the denominator is going to have this term right here. So let's put that in. Your blood flow times 1 minus your hematocrit. Now, your numerator is going to be this term up here. Your replacement fluid or your dialysate fluid, whatever it happens to be, and add that to whatever you're taking out from the patient, which is your ultrafiltration rate. So this is your filtration fraction equation. Now let's talk a little bit about this. If you want to aggressively remove fluid from a patient, you're going to go up on their ultrafiltration rate. When you do that, you're going to go up on the filtration fraction. You're going to be removing more fluid from the patient. And when you get to higher filtration fraction numbers, greater than 20% in some studies, you're increasing the likelihood that you're going to have a filter clot off. So going up on the ultrafiltration rate, while very easy to do by just setting your machine to a higher rate, can cause your filter to clot and have multiple reattempts at starting CRRT. So that might not be the greatest strategy. If you're going to increase your ultrafiltration rate, you may also want to increase your blood flow so that you keep your filtration fraction pretty much the same. Now, we can clean up this equation a little bit further, or actually add in some more variables to make it a little bit more accurate. let's write down what we've got so far. Filtration fraction is equaling your replacement or your dialysate flow rate plus what you take out from the patient, that's the ultrafiltration rate, divided by renal plasma flow. But if you remember, and this is especially the case when you have CVVH, you've got blood flow going in this way, but you've also got replacement fluid in here. So the denominator should include both your blood flow, which is there, and your replacement fluid here. So if you're going to calculate a filtration fraction for CVVH, and you really want to be accurate, you can modify your equation to include the replacement fluid. So say replacement fluid plus your ultrafiltration rate. And now we're going to divide that by the sum of your replacement fluid again, plus your blood flow that's being multiplied by 1 minus your hematocrit. And that's a more accurate way of getting your filtration fraction for CVVH. But the best thing for you to do is to just use a formula that's based on this architecture up here, because you really can't go wrong, and keep your filtration fraction under 20% if at all possible by adjusting your blood flow or adjusting your ultrafiltration rate or your dialysate flow rate or your replacement fluid flow rate, and that way you can keep your filter running smoothly for hours and hours on end and hopefully keep yourself from being woken up in the middle of the night. And that's the filtration fraction. Thank you very much.